Hi everyone, this is Ayushmaan, network engineer at GeekyAnts. So today we'll be explaining about like how we have set up the Zabbix for like monitoring tool for our infrastructure. We have used Zabbix tool as our monitoring tool here at GeekyAnts. So let's suppose if we have an organization, very small organization, they will have only 20 to 50 network components or devices or the resources which uses internet. But what if you have 500 to 10,000 servers, network components, or the services or the applications you're using into your organization? What you will do? How you will monitor that all those devices and the applications? So we come across this Zabbix tool, and now this has provided us many things. So here, me and Girish both will be explaining you the half of the part, like why we have opted or selected Zabbix, what is Zabbix, and how we are configuring our network components to be monitored using this particular tool. So this was the problem statement which I have told you right now. So this is a Zabbix tool. This is an open source monitoring tool to monitor network components, servers, applications, websites, and also the databases. Here is the content of the complete talk, what we are going to explain you. So at first, what is Zabbix? So Zabbix is an open source tool which helps you monitor network components, hardware level failures, as well as the applications. Suppose you have hosted a website, it goes down. How will you get to know that it is down? So we actually use Zabbix agent, and also it uses the agentless thing. Over there in the agentless, it uses SNMP protocol, ICMP pings to like directly ping those like network components, also the hardwares, everything, and then it collects the data. It collects data using SNMP, also using the Zabbix agent directly installed onto the network component. So why Zabbix? So we were searching for a monitoring tool. At first, we had only 50 network components in our office. So we at that time we used Uptime Robot for monitoring. If anything goes down, it actually it used to send us a message. But now when we have like scaled up our infrastructure, now we need a monitoring tool to enhance the hardware failure, like report us with the hardware failures and also with the network state if it is down or up. So here we saw like health of the hardware. Like suppose some of the hard disk is failed, it's failed. So you won't be knowing it at the same moment. So this was problem with us. So we use this software to monitor the health of hardware, state of network, the all those network management network, internet network, like the public network or the private network. So it provides us comprehensive monitoring using agent and also without the agent. Also, it provides us with the live network graphs, diagrams to monitor the real-time scenarios. It has also flexible alerts. Flexible alerts, I'll tell you. You can directly point out the port-wise alerts, service alerts, and also the network interfaces if it goes down. Like like particular alerts you can configure onto your notification systems. So here currently we are monitoring at hardware level, network level, and application level. It has features such as data gathering. It gathers data using agent and without agent. Whenever I'm saying it is without agent, it uses the protocol SNMP, Simple Network Management Protocol. For the alerting things, it has templates which has triggers to alert that like to alert us with if something goes down. Then we have live network maps, which Girish will show you how live network maps looks like. Again, we have historical data storage for the previous thing, whatever happened, to analysis, like to analyze that in future if something happens, how we will be taking an action to resolve that issue. Then we have REST APIs. This APIs help us to create a new application, work with Zabbix, also to integrate Zabbix with third-party applications, and for recurring tasks. Now, network discovery. So, network discovery here in Zabbix, there is a function, or you can say a feature, which actually helps us to discover each and every network component on that particular network using ICMP pings. Then here, ease of the configuration, it is in the way. Suppose you want to add a network component onto the Zabbix. So it is like you have to configure a discovery process for that particular network range, and you'll give the pool of IPs into that configuration so that it will discover all those components which are residing within that pool of IPs. Okay, now over to you, Girish.
Hello everyone. Myself Girish, Junior Network Engineer at GeekyAnts. So today I'll be giving a brief overview and how Zabbix plays a crucial or role in monitoring our data center environments and our network infrastructure. So these are the key components of Zabbix currently. The first thing is the Zabbix database. It is responsible for storing all the collected data from the hosts and the devices, which are the virtual machines, application servers, everything. And Zabbix also supports databases such as MySQL, PostgreSQL, Oracle, etc. And we have the Zabbix server. Zabbix server, it plays a vital role in the monitoring process, because uh, the Zabbix server is the central part of the whole Zabbix architecture system. So any data that is fetched from the servers is directly sent to the Zabbix server, and it manages the overall activity of the monitoring process. So the next one is the Zabbix agent. Uh, Suppose we don't receive any SNMP data from the host, or the IPMI protocol doesn't work. So this comes into picture where the Zabbix agent responds to the Zabbix server about all the health and status of the applications and the devices present in our data center, or suppose our office networks, any network it can be. So the next one is the Zabbix proxy. The Zabbix proxy basically acts as an intermediate between the Zabbix servers and the Zabbix agent. Uh, it reduces the offload on the Zabbix server. It takes the load, then makes it easier and reduces downtime. Next, we have the trapper. The trapper is uh, suppose we don't want any data from the host, but when the host wanna communicate to the Zabbix server about the any breakdowns or issues, we supply a parameter to the keys in the form of trappers, and then the trapper responds to it and directly sends the data to the Zabbix server. So next we have the Zabbix APIs. APIs, we use REST APIs. In GeekyAnts, we integrated this Zabbix monitoring system with our Slack. So any triggers, any breakdowns, any issues in our data center, it directly responds to us in Slack, and we get the notification and immediately take action towards it. Uh, Next, the final part is the UI. The UI, the web interface. So this gives us a clear picture of how the uh, servers, the connections, the data that is passed toward, and the devices which are connected to the servers, switches, routers, etc. Suppose something goes down, we can directly rectify it, seeing the interface. It has dashboards, it has maps. So this basically gives us an overview of how things can be managed easily by just visualizing by network administrators. So what are the benefits that it offers? So first thing, it is open source. So everyone, any enterprises can go towards Zabbix as it as an optimal solution for them. Then it is highly scalable. Large scale and small scale industries can use this and make use of it whenever they want to set up a data center and monitor their devices. Next, we have reusable templates. This is a better feature that is available in Zabbix, where the same template can be applied to multiple hosts, and it makes our jobs easier. Suppose we have multiple switches. Suppose we have a 24-bit switch and a 48-port same Cisco switch. Both are different, but the same template can be applied to both and makes our job easier to add the OS inside Zabbix. Next, we have a powerful visualization through maps. This is the live network maps. As Ayushmaan was saying, anything that goes down, the links get triggered. Then as soon as we see the links and any downtime occurs in the connections, so we can easily rectify it uh, instead of going and checking every links and monitoring every individual links which goes down and what is up. So this provides a better visualization process. Next, we have strong reporting feature. The problems that are triggered in Zabbix have its own classifications. Like there are disaster, high, not classified, and medium level problems, which are average problems. So based on these classifications, anything can be reported to the Zabbix server, and this is done by the Zabbix agent. Then we can take a necessary precaution towards it. Next, high-end community support. As it is an open source, so we are getting more support from online platforms. So this makes a better choice for us. So this is the dashboard for our data center platform, Zabbix.bold. So this is how it looks like. It has its own widgets. It is similar to the widgets that we use in our mobile phones. We can customize it to our own wish. And these are the uh, devices that are added. Any problems that occur are triggered here. And as you can see, uh, these problems are classified into different parts, like by severity. So not classified are those problems which doesn't need immediate action, but which can be considered. Warning is just a warning, and uh, which can be rectified for in the future. And we have informational problems. These informational problems are like uh, there is no need of immediate action. Suppose a disk fails and we have to replace it. So these informations are pretty necessary for it. Then we have average and average problems. They are moderate problems which might cause any issue in the future. So we can easily rectify them. Then we have the high and disaster. These cause more severity in so any issues that occur in the you know data center, so we can easily rectify it through this high end disaster. These may cause performance issues and operational issues and unavailability of the host, so this needs proper attention. So this is how our host looks like. These are the MNT switches, public switches, private switches, the router OS, the main router OS, through which the uplink are sent to all the racks. So this is pretty important for us. Then the chassis slots, we have blade servers, storage servers, rack servers, Cisco switches, MikroTik switches, routers, and any issue in these devices can be easily rectified once we add the host here and enable the SNMP for that. It works on port 161. Then we have the latest data for every refresh interval of 1 minute or whatever customization we set. The data will be fetched from this and will be reflected. So these are the latest data that are available. You can also see the CPU utilization. Zabbix also supports graphs. Next, coming to the maps, these are the three types of maps which are based on the data center network, where the MNT network, public network, and private network comes into action. So the public network, so I've like divided it into racks. So this is the router OS I was talking about. Uh, this is responsible for sending the data to the switches. From there, it passes to the rack switches. From there, the data is transferred to all the public switches in the racks. From there to the servers. So any issue, it will be directly reflected here. The triggering will cause the change of the links to green, and so we can easily find out which links went where, and what breakdown has caused this issue. Suppose we can see here, this is the informational problems I was saying. System status and critical, so it needs attention but not immediate one. This is the CPU temperature. This one has 4 problems. Suppose a link down issue has occurred, so this will be triggered. Next, we have discovery. Discovery can be done by 3 ways. It is by the IP address, by the SNMP agent, and the Zabbix agent. These 3 are responsible for discovery. Once the host is added, a similar macro is sent to the hosts and the Zabbix server. When they both verify, then the SNMP status is checked, and the host is discovered, and these are the discovered devices which comes under discovery. Next, we have services. Services are nothing but applications and databases or servers that comes up. This is the inventory data, and these are the configurations. This is host group. Suppose we want to classify our Dell products into some separate under separate manufacturer, so we can divide them and group it under a similar host. We have SNMP cards installed even for our UPS and other devices, virtual machines, hypervisors. So the reports give us the system information, how many hosts are running, how many templates are available. Everything can be monitored using Zabbix. This is mostly on the administration role. Here we can see the images that can be downloaded, and based on the devices in our infrastructure, we can add it to our network maps, and this makes our work even easier. So to identify which device is which. So this is basically about the data center. Now I'll be moving forward to our Infra Zabbix, which is used to monitor all the virtual machines and the OpenStack cloud, which is available. And here you can see these are the services which we are monitoring currently. So AODH is an alarming system. Barbican has the secret keys and encryption keys and OpenStack. We have Cinder. It is basically a block storage volume allocated by OpenStack. We have pretty much important things like Keystone for API client authentication. Then we have MySQL. It acts as a primary storage system for us. Then we have Nova. Nova is basically for hosting and managing the cloud systems. We have placement to keep the track and inventory of all the cloud resources that we are using. So this gives us a clear picture of how many CPU utilization the virtual machines takes, the amount of disk storage it takes, and the free space that is available, the swap space. Everything can be monitored using this dashboard. So these are the machines available in OpenStack. LXD is basically the container which holds the OpenStack infrastructure. So everything, every virtual machine or the compute engines all come inside the LXD container. So this side menu is basically the same for all the three Zabbix platforms. So I'll be moving to the Office network. So this is the Office network. This is very useful for us to monitor all the access points, the routers, the switches which we use in the Office network. So you can see the triggers that are available here. One of the link in cafeteria has gone down, so it is coming up here. And we've also designed the maps for the Office network. So this is the West building, and this is the East building which we are standing on. One sec. Okay, this is the East building. These are the devices inside the racks which can be monitored. We can see the triggers, here, and the firewall we are using. So this is connected through a fiber channel link, which connects both the buildings from here to there. So any issue that comes up can be easily rectified by us. So as I said, these are the trigger actions available, a service discovery, internal actions that can be taken place. This is the Omada controller that we use for assigning the Wi-Fi. So pretty much this is how Zabbix helps us with its sophisticated technology to monitor every devices and make our jobs easier, and we can easily identify whether any outbreak causes in our total infrastructure. So that's it, guys.